Hello everyone, I hope you're doing well today. So if you have not watched yet my first video on chapter 8, which is about stoichiometry, I would encourage you to watch that video before proceeding to listen to this video, which is going to be a review and summary of that topic of stoichiometry. We're going to work two practice problems in this little video to review those concepts. So I would encourage you to watch the previous video that I've posted on Canvas before proceeding further. So this little diagram that I have up here is just to summarize two important points about stoichiometry. So stoichiometry is just a fancy word chemists use to say something about amount of product and reactant in a balanced chemical equation. So if I have a balanced chemical equation like this one I have up front, I have hydrogen gas reacting with oxygen gas to give you liquid water. In a balanced chemical equation, those coefficients, those numbers out front, relate amount of reactant and product, not just on a molecule level, but more importantly on a mole level. So from a balanced chemical equation, I use those coefficients to say something about moles of reactant and moles of product. So for example, in this chemical equation up front, I can say for every 2 moles of hydrogen gas and every 1 mole of oxygen gas, if there's no coefficient out front, then it's an implied 1. For every 2 moles of hydrogen gas, I have 1 mole of oxygen gas. I would have 2 moles of liquid water produced. Okay? So coefficients from a balanced chemical equation. That's where number type of atom on the left equals number type of atom on the right. Coefficients from a balanced chemical equation relate moles of reactant and moles of product. That's the first point. The second point is that we can take those moles and convert them to grams using the molar mass of the particular substance. Okay? So 2 moles of hydrogen gas, that's equal to 4 grams. We can convert that using the molar mass of hydrogen, which is 1.01 grams per mole. Okay? I could do something similar with oxygen and water. Note that I cannot say for every 2 grams of water, there's 1 gram of oxygen. Those coefficients of the balanced chemical equation relate moles. Moles. I can only get to grams. That's what we weigh out in lab when we ever have lab again. We can only get to grams by converting through that substance's molar mass. Okay? So that's what this first little summary diagram is for. This second cartoon summarizes the steps that we can use from a balanced chemical equation to do stoichiometry calculations, or basically calculate amount of product given a particular amount of reactant. So let's say I had some substance, I had grams of some substance A, like in this case hydrogen. Let's say I had grams of hydrogen and I wanted to find grams of water produced. There's no direct pathway to go directly from grams of one substance to grams of another. The only way that connects reactant and product is through the coefficients of the balanced chemical equation, and those coefficients of the balanced chemical equation relate moles, not grams. So if I was given grams of some reactant, let's say hydrogen, and I needed to get to grams of some product, let's say water, I'm going to have to use the coefficients of the balanced chemical equation to do that in terms of moles. But before I do that, I have to use the molar mass of my species to go from grams to moles. Once I do that, then I can use the coefficients of the balanced chemical equation to relate moles of one substance to moles of another. And then if I need to find grams of some substance, then I can use the molar mass of that substance written as a proportion to do that calculation. Okay? So this little dance of going from grams of one substance to moles of that same substance using its molar mass, to moles of that substance, to moles of another substance from the coefficients of the balanced equation, and then back to grams using the molar mass of what we're looking for. That's going to be a three-step process, a three-step dance that's going to be very useful in this chapter. And you're going to be using that process when doing problems 2 and 3 on your Canvas worksheet. And we're going to do an example now that should be helpful to you when doing those problems. So let's say I give you this balanced chemical equation. I have 2 KClO3 solid decomposing to give you 2 moles of potassium chloride and 3 moles of oxygen gas. And I want to know how many grams of oxygen form when I have 2.72 grams of KClO3. So to do that problem, which I've written down here, and I have the little guide, the little flow chart up here. To do that problem, we'll start out just like we do with other dimensional analysis problems. Write down what we're given, give ourselves some space to work the problem, write down what we're looking for. In this case, we're looking for grams of oxygen. So we have grams of one substance, in this case KClO3. I need to get to grams of something else. And to do that, I'm going to use this flowchart, along with information from the balanced chemical equation. So let's get started. So I have grams of some substance. I got to get to moles of it. I'm going to use the molar mass of A, specifically KClO3. So you get your periodic table. You add up the mass of 1 potassium, 1 chlorine, and 3 oxygens. You should get 122.55. That's how many grams are in 1 mole of KClO3. You write that as a conversion factor appropriately so that your gram units cancel. So I'm now left with moles of KClO3. So I am now right here in my little flow chart. So we're at moles of substance A, KClO3. Now I'm at the point I can finally get to moles of B, or oxygen, by using the coefficients of the balanced chemical equation. And so I see here that for every 2 moles of KClO3, I have 3 moles excuse me, of oxygen gas. So I will write that appropriately here so that my mole KClO3 units cancel. I now have moles of oxygen gas as my unit. So I'm now at moles of substance B of oxygen. I'm almost to where I need to be in terms of grams of oxygen. To get to moles of to go from moles of oxygen to grams of oxygen, I need to use the molar mass of oxygen, specifically the molar mass of O2. So the molar mass of O2, 32, because you have 16 for each oxygen multiplied by 2. Written this way, so my mole of O2 units cancel. So I'm left with grams of oxygen in my numerator. That's great. I'm now at the stopping point. I'm at the unit that I want for my answer. So everything in the numerator multiplied, everything in the denominator divided. And what should come out of your calculator is 1.0653. But if I was to write it to 3 sig figs, just because that's what's given to me, this number written to 3 sig figs is 1.07. So I have 1.07 grams of oxygen gas that came from the decomposition of 2.72 grams of KClO3. And I found that by first converting my grams to moles using the appropriate molar mass, going from moles of that substance to moles of the substance that I'm looking for using the coefficients of the balanced chemical equation. And then I went back to grams of the product I'm interested in by using its molar mass. Okay? So that's how you attack a problem like this. So I would recommend, if you have not already, trying all the parts for problems 1 through 3 on the Chapter 8 Canvas worksheet. You're going to use the same series of steps. Check your answers. The answers are on Canvas as well. The next video topic will be a separate video. It'll be on limiting reactant, and that concept you will use on problem 4 of the Canvas worksheet.